All right, everybody can bring their attention back to the front. Please welcome the gene therapy vectors.
Good morning. Can y'all hear me? Okay. So this morning we'll be presenting on gene therapy vectors. I'm Maggie Nix. This is Seth Etcherson. Cindy Sheridan. That's Harrison Musselroom. That's Smith. Hello. For gene therapy is the use of genes to correct genetic disorders that can be fatal. And these diseases and disorders that have been able to be treated range from cystic fibrosis to cancer and many others as shown on the chart. For our proposal, we would like to research more into effective vectors that will help with the gene therapy, as many of the vectors have the ability to cause immune system reactions and even can be very inconsistent, meaning they won't work. These vectors are the system of delivery of the gene therapy into the patient's cells as it introduces the new genetic sequence into the cells by inserting the DNA right into the sequence. So these mutated genes then have the ability to be reversed, meaning that the person will either be able to treat or even cure these diseases. As this increases, they can use either non-viral or viral vectors. The non-viral vectors mean that it's either like a nasal spray that can just be inhaled and it will insert itself, or they're viral vectors that some have been shown to have immune reactions because it is a virus, but it's actually attempting to insert the corrected DNA into the sequence. This is very important as gene therapy increases in accessibility to the public, because it needs to be able to be safe and effective. And if these vectors are safe and effective, they have the ability to save many lives.
There are many institutes and universities working on gene therapy vectors right now, such as Harvard, MIT, and UVA. Right now, they're looking at which one might be better, and also finding the line between good and bad, which people have been trying to do for several years. Right now, they're working on trial runs. When is the right time, and how would you use it? And right now, they're trying to perfect it because it's a long way from perfect. There's still a lot of flaws in it, such as cost, availability, whether it will actually work or not. and efficiency.
The issues addressed in our topic are the improvement of vectors, and this leads into the expansion into more diseases, such as cancer and other diseases that you know. The vectors need more attention because of the fact that they are still flawed, such as viral vectors, although they are used much more commonly than non-viral vectors, cause immune responses. And although there is the alternative of non-viral vectors, they're still very unreliable. The most important action that can be taken is research and clinical trials. Although that is the most important way to improve these vectors because they are such a specific part of gene therapy.
In order to improve the performance of viral and non-viral vectors and their ability to transport DNA, we believe extensive research is the best action to take. This is an important action to take because gene therapy could potentially cure many major diseases such as cancer, HIV/AIDS, heart disease, and many more. Unfortunately, components of gene therapy have not yet been perfected. Vectors are a vital component of gene therapy because they are needed to transport DNA to cells where they replace mutated genes with healthy genes. On occasion, these vectors may cause an immune response or infect the wrong types of cells. However, if these issues can be solved through further research, then gene therapy could become a very successful treatment. The hope would then be to spread this treatment to a wider variety of diseases and allow a greater number of clinical trials to become available. Increased success may also cause the government to ease restrictions on gene therapy and allow it to become more accessible. Taking action through further research is the best way to address this issue because the only way we're going to discover the full potential of gene therapy is through its trial and usage. It's a novel treatment that definitely has its flaws, yet searching for alternatives will not allow us to improve or advance this treatment. Finding ways to improve gene therapy and its components is the best action to take concerning this issue.
We will do all of this by hiring the scientists at the Viral Vector Core Laboratory, and we will use their wide variety of viral vectors to find the best viral vector that will transfer the DNA successfully with no negative immune responses. And we will also use the resources at the Harvard Medical School and Harvard University. They also have a wide variety of viral vectors that we can use, and they also are experimenting and researching at a low budget. We will conduct 1 year of research, and we will have a 4 to 6 year long clinical trial to test the different viral vectors, and we will also use the viral vectors on different diseases. And then at the end, we will evaluate our results, and successful results for our clinical trial will be no negative immune responses, and we're also looking for a low cost of these gene therapy vectors. And we will do all of this under a $150,000 budget.
So as we continue to experiment in many universities and initiatives across the country, such as UPA and Harvard, there can be an increase in knowledge greatly. This knowledge can range from the improvement of vectors to even the best possible way to use gene therapy to treat many fatal diseases. Many of these issues that are addressed include those that these viral vectors can have immune reactions, but if we can find a way to eliminate that, these also have a great possibility because they can be very accurate in where they insert the DNA. As the research continues, it is important that we look into the usage of certain vectors into different diseases, as some vectors might not react as well with the mutated gene. Although some of these can improve life quality for many people, it has the ability to improve our future generations' health in many ways. As we begin the experimentation process, it is necessary for us to be funded with about $156,000 to get through the experimentation, testing, and the beginning stages of the clinical trials. With these experiments, hopefully we will find the most efficient and effective vector that will help patients with their disease, that it may be just a treatment that makes their lives easier on them. And it also has the ability to take care of some disease. And with this, in the short term, it can improve patients' life and their families' life. The quality of their lives may become much greater than it was before. While in the long run, it really does have the possibility to improve public health for many generations to come. Thank you for your time.
Whoever would like to address the logistics of the budget. I didn't hear anything for, if I'm giving you $156,000, where is that going?
So a majority of it is actually going to
Okay, so our budget is going to go towards the scientists at the Viral Vector Core Laboratory and to Harvard, because they will be conducting our research for us, and then it will also go to our clinical trial as well.
So it's going to be paid towards one of the MIT, Harvard, one of the suggested institutes that are already working on the vectors, where you want to put that money to them, is what you're saying.
Yes, and also our clinical trial.
That's one of my questions. The other question I had is, can you describe test subjects for these viral vectors? So moving past the experimentation and testing, once you move into clinical trials, what test subjects do you use for tracking the vectors?
So we're just going to be testing different types of genetic diseases, specifically cancer and HIV.
So test subjects, would you be using animals, would you be using
Mammals at first, and then if our research progresses, we can use humans if it's approved.
Did you factor any of that cost of purchasing test subjects, managing test subjects? Is that part of your funding in that $156,000 that you asked for?
Yes, we broke it down into maintenance and supplies and actually carrying it out. So,
Can you tell us what the mix of it is? And
You don't have a slide for it.
can you tell us about
maintenance was around 100,000, maybe a little higher. Carrying it out. Then maintenance was around 2,000.
2,000?
Yes. And then to actually fund, like get started funding, that was 42,000 just to pay the institute for university.
as for the research component or the experimentation?
Yes.
So you gave us three components. The breakdown was experimentation, testing, and I assume that's part of the research. And if I'm wrong, correctly, testing and then clinical trials.
Yes.
So can you give us a cost, so for the $156,000 that you're asking from me, can you give me a breakdown? If you can't do it with the clinical trials, can you do it with those three components for us?
Then help you go back to the text.
Yeah, you can look at the
Yeah,
slide.
go back to the.
So a majority of our funding is aimed more towards the clinical trials because that will show our most how the reactions to the actual vectors go most occur.
Do you have a number for that?
That was close to about 8,000 because that was our highest price.
Very good.
Thank you.